Hello everyone, welcome to your channel Data Science Studio, and today we are going to start with day 4 of statistics for data science. So let's get started. So in today's session we are going to discuss about some of the important concepts of measures of dispersion, which is very important from data science perspective, which is like what is your inter-quartile range, what is mean absolute deviation, what is standard deviation, and what is Chebyshev theorem, and what is empirical rule. So when we talk about measure of dispersion, so before starting measure of dispersion, we have to understand that what is the drawback with measures of central tendency. So the measures of central tendency actually describes the central value of the data set, but these measures do not explain how these values are dispersed or scattered on each side of the central value. So for example, let's say that I am taking one example where I have a shop 1 and I have shop 2, and the sales of shop 1 is 10 and 100 on D1, day 1 and day 2, and the sales of shop 2 is 40 and 70. So if I take the mean of both the days, it is 55. So even though the mean is same, the values on days are different for the two shops. So which means that the measures of central tendency is not the only criteria to explain the dispersion of the data around the mean value. So in this example, even though the mean is same, but data for two shops sales is different. Therefore, it is necessary for us to understand data by measuring dispersion. And there are various ways in which the dispersion can be measured. One is called as range. Secondly, we have something called as quartile deviation. So we have range, inter-quartile deviation, mean absolute deviation, variance and standard deviation. Now what is the difference between absolute measure and relative measure? It is very important to understand. So what is absolute measure? So in absolute measure, it involves the units of measurement. So it involves the measures of units of measurement. So for example, the dispersion of salary of employees is expressed in rupees. So in case of absolute measure, the salary will be expressed in INR, which is rupees. Now, due to this drawback, the absolute measure cannot be used to compare two different set of variables. For example, I cannot compare the absolute measure of salary with respect to age because both are in different units, and hence we go with relative measure. So what is relative measure? In case of relative measure, we divide the absolute measure by mean or median. We divide the absolute measure by mean or median to derive the coefficient of all these absolute measures. So we derive the coefficient of range, coefficient of quartile deviation, coefficient of mean absolute deviation, and coefficient of variation. So let's see all these one by one. So first, what is range? We have to understand what is range. So range is actually the difference between the largest and smallest observation in the data set. So here I have one data set. So my range is actually the difference between the largest and smallest value. So what is the largest value over here? The largest value over here is 86 and the smallest value is 20. So my range is 66. So this is the range in which my data is spread. And what is coefficient of range? So coefficient of range is equal to L minus L S divided by L plus S. So which is 86 minus 20 divided by 86 plus 20, which is again equal to 66 divided by 106. So my coefficient is 0.622, which means higher this value, higher is the variation in the data set in terms of extreme values, because range takes the extreme values only, which is lowest and largest and smallest. Now, one of the disadvantage of range is the calculation of range is based only on two values, which is largest and smallest, and it fails to account for all the other observations. That's why range alone is not the right metric to calculate the measure of dispersion. Now, where range is useful? So, where range is useful in those situations where even a small variation among the values in the data set happens. For example, in case of stock market or in case of the share prices of a share, if there is a small change in the share, the range will change. So, next topic is what is interquartile range. So, the interquartile range is a measure of dispersion or spread of values around the between the third quartile and the first quartile. So what is interquartile range? Interquartile range is Q3 minus Q1. So my IQR is equal to Q3 minus Q1. Now if I divide the IQR by 2, if I do Q3 minus Q1 divided by 2, that becomes the quartile deviation. So this is called as quartile deviation. Now, half the distance between Q1 and Q3 is called the semi-interquartile range or quartile deviation. Now, what we have to interpret from here is the smaller is this value. The smaller is this value, the less variation among the middle 50% of the observations. So here we are talking about only middle 50% of observations. And high value of quartile deviation, if the value of quartile deviation is high, then it indicates large variation among the middle 50% of the observed values. So higher the difference, higher the value of QD, higher the variation, lower the QD, lower the variation. So what is my coefficient of QD? So coefficient of QD is equal to Q3 minus Q1 divided by Q3 plus Q1, and this coefficient can be compared across different variables. Now quartile, if you have seen the last session, the Q3 is 3 into n plus 1 th by 4 and Q1 is n plus 1 th item by 4. So if you put all the values, your Q1 will be 32.25 and your Q3 will be 76.75. So my quartile deviation is equal to difference between the two, which is 76.75 minus 32.25 divided by 2, which is 22.25. This is your quartile deviation. And what is the coefficient of quartile deviation? Coefficient of quartile deviation is 22.5 divided by 109, which is equal to 0.204. Now, what is the drawback with interquartile range? So, the drawback with interquartile range is it considers only the middle 50% of the value. So, it considers only middle 50% of values. So that's why IQR is mainly used for outlier detection. So we want to use IQR only for outlier detection, and that's why IQR is also not a very great metric to measure the dispersion of the data. And hence we have some more metrics like mean absolute deviation and standard deviation. So what is mean absolute deviation? So the range and quartile deviation indicate overall variation in a data set, but they do not explain the spread around mean. Now, to understand the nature of distribution of values in the data set, we need to measure the spread of values around the mean, and we have two measures of dispersion to measure the mean amount by which all values in the data set varies from the mean. And first is called as mean absolute deviation, or we call it as a average deviation. So what is mean absolute deviation? So the formula for mean absolute deviation is MAD is equal to 1 by n sigma absolute value x bar x minus mu, this is x only, x minus mu divided by n, so which is I equal to 1 to n. So this is for population, and for sample the n will become the small n, sigma x minus mu I equal to 1 to n. So most of the time we work with sample. Now what we are doing over here, we have the sales data for 10 days and we have calculated the mean value and we have calculated the x minus mean. Why we cannot use x minus mean? Because if you take the summation of all the values, it will become 0. And that's why we take the absolute value so that the sum is not 0. So my mean absolute deviation is 209 divided by 10 is equal to 20.9. And now this is a absolute measure, so I cannot use this to compare different variables, and hence I have to calculate the coefficient of mean absolute deviation, which is mean absolute deviation divided by mean. So my coefficient of absolute deviation, mean absolute deviation will be 20.9 divided by 55.7, which is 0.375. So higher this value, higher the variation of the data from the mean, because this value will become lower. And What we infer from this 20.9? So on the average, the mean difference between individual values and the mean is 20.9. That is how you have to infer the mean absolute deviation. Next is called as variance and standard deviation. Everything is same. In this one, what we do, instead of taking the absolute, we take the square, which is over here. Instead of taking the absolute, we take the square, and my population variance is sigma square equal to 1 by n, sigma I equal to 1 to n, xi minus mu whole square. This is for population. For sample, there is a change. We divide it by n minus 1. So for sample, sigma square is equal to sigma x minus x bar whole square divided by n minus 1. And why we divide it by n minus 1 in case of sample? So the reason is, if the sum of the square deviation about a sample mean is divided by n, so if we divide this by n, then it actually invariably cause the bias on the actual value. So when we are predicting the population variance from the sample variance, it will be low. That's why to remove this bias, we divide it by n minus 1, so that your sample variance is actually representing the population variance and there is no bias. So to remove the bias, we divide it by n minus 1, and this is called as, when we divide it by n minus 1, it is called as unbiased sample variance. And the numerator x minus x bar ka whole square, this is called as total sum of squares. This is called as total sum of squares, and this quantity actually measures the total variation among values in a data set. And the larger this value is, the greater the variation among the values in a data set. So my s square will be, this is the difference, 5038.1 divided by 10 minus 1, which is 559.79. Now variance alone is difficult to interpret because it is the square of the values, and that's why we use standard deviation. So what is standard deviation? Standard deviation is actually square root of variance. Standard deviation is square root of variance. So my square root of 559.79 will become 23.66. So now you can compare that your mean absolute deviation was 20.9 and your standard deviation is 23.6, which is more accurate and it is representing the population variance correctly. So I can say that on an average, the difference between the sales of different days from the mean is 23.66 units. And if you want to compare this along with different units, you have to calculate the coefficient of variation. And what is coefficient of variation? So coefficient of variation is equal to standard deviation divided by mean into 100. So here it will be, you can calculate it, the coefficient of variation will be 23.66 divided by 55.7 into 100. So this will be your coefficient of variation. And coefficient of variation is an important matrix when you want to consider the variation between two different variables in your machine learning models. So you should be very clear with what is coefficient of mean absolute deviation, what is coefficient of variation, and why coefficient of variation is better than mean absolute deviation. Now, next important point which we are discussing is called as Chebyshev theorem. So, Chebyshev theorem is actually given by a Russian mathematician, which is P.L. Chebyshev. And this theorem states that for a given set of data and a constant parameter z, the proportion of values that lie within z standard deviation on both sides of the mean is 1 minus 1 by z square. Now what does Chebyshev theorem says? Now Chebyshev theorem is applicable regardless of the shape of the data. So even if your data is skewed like this, whether it is a negatively skewed or it is positively skewed or it is normally distributed, this theorem is applicable. So now how do we calculate how much amount of data lies between certain standard deviation? So if we calculate mu plus minus 2 standard deviation, which is the z value is 2, 1 minus 1 by 2 square, which is 3 by 4, which is 75%. So regardless of the distribution of the data, 75% of the values will lie within 2 standard deviation of the mean. 2 standard deviation of the mean means if your mean like this is a normal distribution and this is a mu. So this is your mu plus 2 sigma. And this is also your mu plus 2 sigma, a rough figure. So your 75% of the values will lie between 2 standard deviation. And if we talk about 3 standard deviation, then it will become 1 minus 1 by 3 square equal to 8 by 9 is equal to 88.9%. So 88.9% of the values will lie within 3 standard deviation from the mean. And if you do mu plus minus 4 standard deviation, 1 minus 1 by 4 square is equal to 50 by 16 is equal to 93.75%. So this becomes very important that regardless of the shape of the distribution, 93.75% of the values will lie within 4 standard deviation of the mean. Now we will see another topic which is called as empirical rule. Now for symmetrical data, so this is Chebyshev theorem is applicable both for your symmetrical distribution and asymmetrical distribution. Asymmetrical distribution means when your data is skewed, which we will be discussing in day 5 what is skewness. But when your data is not in normally distributed, when your data is not like this, when your data is either like this or your data is like this. So if your data is skewed towards the left side or right side, then this theorem is applicable. But when we talk about empirical rule, it is only applicable for symmetrical distribution. So what is symmetrical distribution? Symmetrical distribution is actually a bell-shaped curve. It is, let me plot it, it looks like this. This is a bell curve and it says that certain percentage of values lies between 1 or 2 standard deviations. So for example, if I go with 1 standard deviation, so 68.27% of values, so let's say this is my mean. So this is mu. So 68% of the values, which is this is a just rough estimate, 68% of the values will lie between one standard deviation. So which is mu plus sigma on both sides. This is mu minus sigma. And 95.45% of values, which is 95.45%. So this is mu plus minus 2 sigma is equal to 95.45% of values will lie between two standard deviation, mu minus 2 sigma, mu plus 2 sigma, and 99.73% of the values will lie between 3 standard deviation of the mean. So mu plus minus 3 sigma is equal to 99.73%. And in our machine learning projects, in our any kind of data science projects, most of the variables should be normally distributed. And this empirical rule talks about normal distribution, which means that within one standard deviation 68.27 will lie. Data points I am talking about for a variable. Within two standard deviation 95.45% of the data lies, and within 3 standard deviation 99.73% of the data lies. And this empirical rule is a very important concept in statistics and in your data science and machine learning project. You should be very clear about what is empirical rule. So that's it for today's session, and in our next session we will be talking about the concepts which we have discussed, what is asymmetric distribution and how to measure it, and we'll be discussing about some of the very important concepts in statistics, which is skewness, movements and kurtosis. So please subscribe, like and comment your channel and provide your valuable feedback on the content, and stay tuned, stay connected. Thank you.